Hi guys, this is Ajit. So we are going to be solving today's LeetCode question, which is bitwise and of numbers, which is in the range from left to right. So we are given two integers, one is left and the other is right, and this contains the all the numbers which are in the range from left to right, and we need to return bitwise and of all the numbers which are in the range. Suppose let's say let's write the numbers in bitwise so that we can understand better. So let's write 1 in binary representation, which will be 0, 0, 1, and then 2 will be represented in 0, 1, 0, and then 3 will be represented like 0, 1, 1, and then 4 will be 1, 0, 0, and then 5 is going to be 1, 0, 1, and then 6 is going to be 1, 1, 0, and then 7 is going to be 1, 1, 1. So the left can be 1 to 1 to till 7, and then right can be like any of these two values can be left and right. So and then left should always be less than or equal to right. So as we can see that the the number is 2 power 20, 2 power 31, which will be like 10 power 9 something, 2 into 10 power 9. So it cannot be solved in big O of n. So we need to think of better approach, which will be like log n or different. It can be big O of 1, or it can be some kind of computation which we'll be doing in bitwise. So if we try to observe this, let's say we want to go from each bit, and there are 3 bits here. Suppose let's take range from 4 to 7. So let's try to decide each digit. Suppose let's take this particular digit 1, and then 1 is matched. So we can write 1, and then 0, and then again 1. So if it is 0 and 1, then we can definitely say that it will be 0. Why? Because it is a AND operation, and we should do the AND operation for all the numbers. As left is also present, so there must be 0. So it will be 0 for this particular digit. And then let's come to the next digit. So let's say if it is matched, suppose let's say for this particular case it will be 0 as well. Why? Because this is also 0 and then 1. And now take different example, which is 5 and then 7. For this particular example, first digit is going to match, and then for the match digit we are going to say 1, and then 0 and then 1. So this particular digit is not matched. So we should write it to 0, and then the next digit is matched 1 and then 1. Is there any number which we can build by making this particular digit as 0? Can we do that? Yeah, we can do the digit to 0 we have when we have previous digit which is unmatched, so let's say this is 1 and 1. It can be taken with 0 by the next number, and we can put 1 in place of this. So it will be in this range only, and then it will contain in this particular range. So whenever we have unmatched digit, whenever we have 0 and then 1, then all the digits which are present, if it is 1, we can make this particular digit as 1 and then write all other digits as 0. So we can say whenever we meet with that particular condition, then we can say all the digits will be 0, and then for this unmatched we are going to stop and then we are going to return the answer. So let's uh, yeah, that's all the intuition behind this. So let's see the code. So we are just taking the answer and then we are moving from right uh, like the rightmost bit, like the leftmost bit till 0th bit, 31st bit to 0th bit. Here we are going to check whether particular digit is matched or not. If it is not matched, then we are going to return answer. Why? Because the all the other digits can be made 0 by changing this particular digit, which is 0 to 1 and then 1 to 0. Suppose let's say if if it is if the if the bit is set, suppose let's say if it is equal to some 1 to the power of I, then we can say that answer will be included. That particular digit is going to be set. 1 to the power I, in the sense it will be like, I mean to say 2 to the power I, which means that particular bit is set, and then at last we are going to return the answer. So let's submit this. Yeah, that's all for this video. Thanks. Yeah, the time complexity for this is going to be big of 31, and then I think big of 1, and then space is going to be big of 1. Yeah, that's all for this video. Thanks for watching.